Welcome to our lesson on relations and their properties. In this video, we'll cover the concept of relations on a set and three key properties: reflexive, symmetric, and transitive. Let's start with the definition of a relation. A relation R on a set A is defined as any subset of the Cartesian product A cross A. In mathematical notation, we write R as a subset of a cross A, and R equals the set of ordered pairs x, y such that x is related to y. Let's visualize this with a simple example. Consider set A equals curly bracket 1, 2, 3, 4 end curly bracket. The Cartesian product A cross A consists of all possible ordered pairs from A. A relation R on set A is any collection of these ordered pairs. For example, R could be the relation is less than, which contains ordered pairs, where the first element is less than the second element. Now, let's study the three main properties of relations. The first property is reflexive. A relation R is reflexive if every element is related to itself. Mathematically, we say for all in A, the ordered pair, A is in R. Let's see an example. The relation equals on the set of integers is reflexive because any number equals itself. For instance, 5 equals 5. A non-example would be the relation is less than on the set of integers. This is not reflexive, since a number can't be less than itself. The second property is symmetric. A relation R is symmetric if whenever A is related to B, then B is related to A as well. Mathematically, for all A and B in A, if the ordered pair AB is in R, then the ordered pair BA is also in R. An example of a symmetric relation is sibling of on a set of people. If Alice is a sibling of Bob, then Bob is also a sibling of Alice. A non-example would be the relation is less than or equal to on the set of real numbers. For instance, 2 is less than or equal to 5, but 5 is not less than or equal to 2. The third property is transitive. A relation R is transitive if whenever R is related to B and B is related to C, then R is related to C. Mathematically, for all A, B, and C in A, if the ordered pair AB is in R and the ordered pair BC is in R, then the ordered pair AC is in R. An example of a transitive relation is less than or equal to on the set of real numbers. If 2 is less than or equal to 5 and 5 is less than or equal to 7, then 2 is less than or equal to 7. A non-example would be the relation is parent of. If Alice is a parent of Bob and Bob is a parent of Charlie, it doesn't mean that Alice is a parent of Charlie. She is a grandparent, not a parent. A relation that possesses all three properties, reflexive, symmetric, and transitive, is called an equivalence relation. Equivalence relations are important in mathematics because they help us group elements based on some shared characteristic. A classic example of an equivalence relation is congruence modulo n on the set of integers. For example, in congruence modulo 3, the integers are grouped as follows. Numbers that give remainder 0 when divided by 3, like 0, 3, 6, numbers that give remainder 1, like 1, 4, 7, and numbers that give remainder 2, like 2, 5, 8. Let's summarize the properties we've learned about relations. A relation is reflexive if every element is related to itself. A relation is symmetric if when A is related to B, then B is related to A. And a relation is transitive if when A is related to B and B is related to C, then A is related to C. Understanding these properties is crucial for further study of equivalence relations, partial orders, and other important mathematical structures in discrete mathematics.